So an ideal gas is an imaginary gas that conforms to all of the assumptions of the kinetic molecular theory. The equation PV equals nRT is known as the ideal gas law, which includes pressure, volume, moles, the ideal gas constant, and temperature. The pressure can be in any of these 4 units. The volume must be in liters, so if it's not, you have to change it to liters. N must be in moles, so if it's not, you have to change it to moles. R could be one of the following constants below in the box, and T must be in Kelvin. So whatever your pressure unit is, you have to use a matching R unit below. So you can see this first one is 0.0821 corresponds with atmospheres, 8.31 corresponds with kilopascals, and 62.4 corresponds with millimeters of mercury. The pressure unit can change. For these calculations, make sure to choose the R that matches the unit of pressure given in the question. Another example problem, what do we have and what are we trying to find? So first, I'm going to go through the problem and I'm going to mark my givens and what I'm trying to find. When the temperature of a rigid hollow sphere containing this many liters of gas, so there's a volume, is held at, and then there's a temperature of 348 degrees Celsius, and we want to make sure that we convert that temperature to Kelvin, so we're going to add 273 to it. The pressure of the gas is 1.87 atmospheres, and this is going to be very important. It's going to tell us which R value to choose, and the question is how many moles? So N is moles, and that's what we're solving for in this problem. So my equation is PV equals nRT. I'm going to go ahead and plug in the values that I've been given. The pressure is 1.87 atmospheres. The volume is 685 liters. It must be in liters, so we don't have to make a change there. We are looking for N, how many moles? So that's my X. Now, R has to have this unit here, and so we're going to go look at our reference chart and look for the R value, and the R we're going to use is with ATMs, which is going to be 0.0821. So this is 0.0821, and then our temperature is 348 plus 273, which is 621. Got to add these together to have my Kelvin temperature here, my temperature. So here we have P times V equals moles, which is what I want to find, times R times T. And now I can solve this in my calculator. Do not start on the side with the X. We'll start over here, 1.87 times 685, and now these guys with the X we get divided by. So we're going to divide by this, divide by this. So to type it into the calculator, we're going to type in these two values first, 1.87 times 685, and now I can come to the other side and I'll hit divided by 0.0821 divided by 621, and we're going to get 25.12. So our final answer is X equals 25.12. And remember, we were solving for moles. So that is the answer in moles. Determine the volume. So V is what I'm trying to find. Determine the volume. Occupied by 0.582 moles. This is our N. We have a temperature here, but it's in Celsius, so we have to add 273 to make it Kelvin. And then we have a pressure here, which is in mmHg, and that's going to tell us which R to choose. So we have PV equals nRT. We're going to put our variables in now. The pressure is 614 mmHg. The volume is what I'm trying to find, so that's my X, equals my moles is 0.582. My R value is going to be the millimeters of mercury from our little reference chart. So if I look here, we find the R value that goes millimeters of mercury is 62.4. So this is 62.4. And then my temperature is 15 plus 273, which is 288. Now we can solve our calculation. Remember, don't start on this side. That's where the x is. We're going to start over here. 0.582 times 62.4 times 288. And then this is on the side of the x, so we're going to divide by that value. So I'll start with the right side, where I will multiply 0.582 times 62.4 times 288. And then I'm going to divide by 614. And that's going to give me 17.03. So x equals 17.03. Since it's volume, that means it's in liters.